Hey everybody, welcome. This is our Unit 1 study guide. So I'm going to go over it, and hopefully you already did it, and you're just checking your answers with me, or coming with ones that you're struggling with. So, number one, translate -4, 6, 5 units to the left, 5 units down. So 5 units to the left means I'm going to subtract, and down means I'm going to subtract. So -4 minus 5 is -9. And then 5 units down, 6 minus 5 is 1. Rotate counterclockwise. So the counterclockwise 90-degree rule for this one, again, counterclockwise, is -yx. And that's going to be, I just flip them right away, and then I see the front one's going to change signs. It's going to be positive 6, 3. I'm going to do all of these. I'm going to show you a quick trick to see, make sure we got them correct. Rotate clockwise 90. So this rule for clockwise 90, again, these are the ones you want to study. So again, we're going to switch them, -6, 3, but the back one's going to become negative, so it's -6, -3. I'll zoom in a little bit. Okay. Rotate 180. That rule is just to change the signs, so we don't change position, so that's 5, -8. Reflecting over the y-axis. When I reflect over the y-axis, I just actually change my front values. That's -2, -10. Again, the y isn't necessarily positive, it just stays the same whatever it was, so it's still -10. X-axis is very similar, except for we changed the y value. And again, we could just graph these if we don't want to do it this way, but that'd be -3 and then become +8. Y equals x line, you just switch them, but not the sign, so we get 3, -7. And then this one we switch and change both signs, so it's -3, +7. Okay, so one of the things you could do is you could just draw a quick little sketch and see where these lie. So, for example, the original point, +3, -6, lies in quadrant 3, and then positive lies, let me see if I got that right. Positive, negative, I'm sorry, is right here. Forget that one. And then positive is up here. So we went that way. That's definitely counterclockwise, and that's 90 degrees, so I feel good about that. This one right here is at 3, -6 as well. So we're here. Negative quadrant is this quadrant, and that right there is 90 clockwise, though, so that's going the opposite direction. And then rotate 180. Yeah, you can do it for all of these. We're at +5, -8. Or sorry, no, I start at -5, +8, so it's up here. And this is going to be at +5, -8, so it's down there. So that is 180 degrees. Doesn't matter which way we go for that. Okay, so just a quick way you could just check. You will have graph paper for your test. If point D is 6, -4, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4. Reflect over the y equals -2. So to find the y equals -2, I just graph y equals -2 and then ask myself, right, is this horizontal or vertical? Well, if it was vertical, that would be the y-axis, which I know is not the right answer, so it has to be horizontal. Everywhere on this line, y does equal 2. So I'm going to reflect this over. I am 2 units away, so I'm going to go 2 units up, and I'm right there, D prime and D, and that is going to be at 6, 0. What's the difference between rigid motion and non-rigid motion? Explain. I'm not going to write it, I'll just say it. Rigid motion keeps the same shape and size. Translations, reflections, and rotations are all examples. Non-rigid motion is if I do a transformation and it changes in some way. That's typically dilation, which changes in size, but we really haven't talked about it. All right, moving on. It's kind of a long study guide, but I'm ready for it. We're going to perform a sequence of transformations. I'm going to slide all points up 6 units, and then I'm going to reflect over the y-axis. So I'm going to use this point, -3, 1, 2, 3, -2. I'm just going to call it A for the sake of calling it A. I'm going to slide it up 6, 1, 2, 3, 4, 5, 6. This would technically be my first maneuver, A prime, and then it says reflect over the y-axis. So here's the y-axis. I could use the rule, but I could always just count. That's 1, 2, 3. So I'm going to go 1, 2, 3. the resting place of a double prime, in my opinion. That's going to be 1, 2, 3, comma 1, 2, 3, 4. So 3, comma 4. There you go. Number 13, we have a table of values, and so this is the original, this is transformed, and I'm trying to figure out this. So I have to judge what's happening from here to here. So I look at -2 and -6, and I say, all right, what happened between -2 and -6? And it looks like we went down 4. So I would say x minus 4, I went left 4. And then I went from 1 to 0, I'm going to say that's y minus 1. I'm going to check that makes sense here. 6 to 2 is minus 4, -1 to -2 is -1, and 1 minus 4 is -3, and -4 minus 1 is -5, so that all checks. So I know my rule is x minus 4, y minus 1, and then I'm going to apply it to this. So I'm going to subtract 4 from 3, that's going to give me -1. Subtract 1 from 4, that's going to give me 3. So I'm going to get -1, comma 3. So again, just check to make sure it works for each of them. Right algebraic rule, that moves a triangle 5 units up, so that's going to be plus to the y, and 5 units, to the left, that's going to be minus x, and 6 units up, that's plus y. So I'm going to get x minus 5 and y plus 6. There we go. Sorry, read that too fast. Write the coordinates of the vertices of the triangle after reflection over the y equals -1 line. So found y equals -1, so that's the line. And we have the image here at -3. Whoa, getting a little crazy. -3, 2. There's A. -1 and 1, 2, 3, 4, 5, 6. Is B, and this one is 6. 1, 2, 3, 4, 5, 6, comma 1 is C. So there's my triangle, and I'm reflecting it over that line, so I'm just going to count. So my new point is here at C prime, and that is at 6, comma -3. And then B is at 1, 2, 3, 4, 5, 6, 7 units away. So I'm going to go 1, 2, 3, 4, 5, 6, 7. There's B prime, which happens to be at -1, comma -8, if I actually count from the vertex. And then this is 1, 2, 3 units away, so 1, 2, 3 units away, that's A prime. Okay, and that A prime is going to be at -3, and that's at -1, 2, 3, 4. So again, we just count. How far are we away from the line? Make sure we equidistant. Rotate a square clockwise, then reflect over the x-axis graph and label the points. Okay. So first thing is, I kind of cheat here, and I like to actually write the original points here, because then I can just apply my rule real fast, because 90 degrees clockwise is y comma -x, and then reflecting over the x-axis is x comma -y. And so if I know the original points, I can actually just apply the rule really fast, and then when I graph it, I can check if it makes sense. So we're at -1, 2, 3, 4, 5, 6, 7, 8 total. So this is 6, -6, and then I think these are all by 8. 1, 2, 3, 4, 6, 7, 8. Yeah, so now it's easier to count. So that's +7. B is going to be at 2, -2, and +6. C is at -3, +2, and D is at -7, +3. Okay, so let's just apply the rule. So we're going to switch them, and the back one becomes different signs. That's going to be 6, and +2, and then this is going to be 2, and that becomes positive, and this is 3, and then the back one becomes positive. So that should be my rotation, and then here I'm just going to change my y value. So 7 minus 6 now, 6 minus 2, 2 minus 3, and 3 minus 7. So I'll do this one in pink, and we'll see where we get. Okay, so +7, +6 is going to be right there, A prime. 6, +2 is B prime. 2, +3, C prime, 3, positive 7, B prime. Oh, right, that's a D prime. D prime. Okay, so let's see, did I do that right? Does that look good? Yeah, it kind of looks weird. But if you look AB, so like this line right here and this line right here are the corresponding sides, and they do form a right angle. And we did go from this side clockwise to this side, so we did make the right rotation. So I feel good about that. Let's graph this last one in blue. We should just be reflecting over the x-axis. So 7, this time negative 6. There's a prime prime, and then 6. Negative 2, there's B prime prime, 2, negative 3, C prime prime, and 3, negative 7, there's D prime. And my golly, that looks like it's reflected over, and so I'm happy with that. All right, those ones take a little while, huh? 18, let's take a look. It says reflect triangle JKL over the y-axis and then rotate 270 clockwise, graph and label. So I'm going to do the same thing. I'm going to actually write what's the points for J, K, and L, and then I'm going to go back and figure out the rest. So this should be an 8x8 grid, so this is, again, 7 on the, looks like 1, 2, 3, 4, 5 on the X, 7 on the Y, so 5, 7. K is 8, 1, and this is 1, 0. And so to rotate 270 clockwise is the same thing as going counterclockwise 90, so that's negative y, x. Oh, I'm sorry, I'll just go over the y-axis first, so we'll move that one over here. And then reflecting over the y-axis, we just changed the x value negative. So this is going to become negative 5, 7, negative 8, 1, and negative 1, 0. Now we're going to switch them. So I'm just going to switch all of them real quick, and then change the front one to be a different sign. That one's not going to change. Let's see how this works. Again, I'll graph in pink. Negative 5, so 1, 2, 3, 4, 5, and positive 7. Here is J prime. Negative 8, 1, there's K prime, and negative 1, 0, L prime. And does that look like a reflection over the y-axis? I would say 100% yes. And let's take our last one. So negative 7, let's see, negative 7 and negative 5. 1, 2, 3, 4, 5. There we go. That's going to be J prime prime. Negative 1, negative 8, K prime prime, and 0 on the x, negative 1, L prime prime. This one might be harder to see, but I'm going clockwise, 90, 180, 270. And so I can see that would make sense. The J is going to end up way over here, K is here. I'm happy with that. All right, write a rule for this transformation below in coordinate notation. It appears this is just a translation. Just remember we go from C to C prime, the other way around. So I'm going to go check from C to C prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9 back. So I'm going to assume it's x minus 9. And then I'm going to go up 1, 2, 3, 4. So that's going to be y plus 4. I should just double check that with another point. You don't want to just check one point, you want to check another point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3, 4. Okay, so I checked with another point. I feel good. That was just a translation. Identify the line of reflection that would map these onto each other. So we have to go into the midpoint. So right between M and S is this point right here, J and P right here. As soon as you get 2 points, you can pretty much just draw a line in. And it's hitting X at 1, so we're going to call that the X equals 1 line. Pretty nice. Okay. Number 21, write a sequence of 2 transformations that will map the preimage to the image. Okay. So let's see. If I do a reflection, I could get that over and then maybe reflect down, but then I don't know if I'll be in position. So I'm going to try a 180 rotation, see if that works. I like to label my points, and then I can apply my rule. My rule for 180 is negative x, negative y, and we'll see where that lands. So this is 0, 3. This is 3, 4. And this is 1, 2. Let's mess that up. So my new points, L prime, M prime, N prime, or at least the ones I'm doing, are going to become 0, negative 3, negative 3, negative 4, and negative 1, negative 2. Let's see how that works. So 0, 1, 2, 3. Now if you have patty paper, that would probably be a lot better way of checking this, but I'm just going to show you how I would do it without patty paper. Negative 3, 1, 2, 3, negative 4, 1, 2, 3, 4. And that's M prime. And then N prime, negative 1, negative 2. Okay, so good news is it looks like it's going to match up perfectly. I just have to translate, so I'm definitely going to do 180-degree rotation. And it looks like I need to go back 1, so x minus 1, and then go down 1, 2, 3, y minus 3. So we translate in. So usually I try and figure out how can I get it into the right orientation so then I can just slide it on top. And that's how I did it. All right, name 3 collinear points. We could do Q, P, T, just 3 points on the same line. Q, P, T, and you just write them as 3 points. 3 non-collinear points I could do is P, Q, P, S. Notice S is not on the line. All 3 of those points cannot be on the same line. So you just switch one. Give another name for QT. Now QT is a long line segment, so it has to be the same length as QT, and the only one that's the same length as QT is TQ. The same segment, just can name it backwards. Give 2 other names for angle 1. Well, that's right here. That's QPR. So again, if I were to kind of like use this, you want to use the vertex of P in the middle of Q and R. So we get QPR, and we can do it the other way, RPQ if we want. Name the 2 sides of angle 2. So angle 2 is right here. We have RP and SP. Now technically they're rays, but if you were just to write them as segments, I'd give you credit. But if I were to do this correctly, they're rays starting at P going towards R and starting at P going towards S. And that's officially how we would do it. Classify SPU. So SPU is kind of like the combo of 3 and 4. It's greater than 90, but not a straight angle, so that's definitely obtuse. And then RPU is a straight line, so that's a straight angle. And algebra. Okay, so adding 3 over 4 plus 2 over 3, we just got to get the bases the same, so multiply by 3, multiply by 4. So top 3 times 3 is 9, 4 times 3 is 12, 2 times 4 is 8, and 3 times 4 is 12. The reason why I multiplied this by 3 and this by 4 to get that 12 so they're the same. Then we just have to add 9 plus 8, which is going to give you 17 over 12, and we're done. All right, this guy right here, we're going to multiply. We can multiply the 2 in first and then do it, which that's what I'll do, 2x plus 6. And then x minus 6. You can do box method here. I'm going to do FOIL. So I'm going to get 2x squared, then minus 12x plus 6x, and then minus 36. So I get 2x squared. This becomes negative 6x minus 36, and we're done. Factor 24 and negative 14. So I want to list out the factors that will make that work. I have 1 and 24, 2 and 12. I see 2 and 12 makes 14. So I'm just going to do a negative 2 and a negative 12 because those will multiply to a positive 24. So we get x minus 2 and x minus 12. This guy right here, I see everything has a 2 I could factor out. So let me factor the 2 out first. And then I'm going to try x factoring, negative 44 and negative 7. And so again, let's list my factors out. I got 1 and 44, 2 and 22. I'm going to use my calculator to figure out some other factors. I don't think 3 goes into it. Probably not, but let's see. I know 4 goes into it, 4 and 11. Ooh, and 4 and 11 would make 7. So we're going to do 4 and 11, and I'll have the 11 be negative to give me a negative 7. So we get x plus 4, x minus 11, 2 out in front. And then some multiplying distributive property, that's going to be 6x plus 21 equals 39. Subtract the 21, and we're going to get 18 equals 6x. Divide by 6, x equals 3. And then over here, we're going to distribute to get 10x minus, that's going to be, what, 35? Plus 4 equals 7x minus 1. Combine like terms right here, and we get 10x minus 31 equals 7x minus 1. Now you want to move the smaller piece, so 7x, I'm going to subtract 7x on both sides to give myself 3x. At the same time, I will also add 31 away, so I'll get 30 on this side, because negative 1 and positive 31, and then divide by 3. Get x equals 10. Alright, thank you. Hope that was helpful. I will see you guys when I see you guys. Which is when I see you guys. Which is when I see you guys.